Hey everyone, this is Matt with Learn Everything About Design, and in today's video, we're going to talk a bit about using surfacing and fusion to create these sort of faded or subtle features. Now, this is a request or a question that I've had and actually has come up quite a bit. And in this case, what we're going to do is something relatively simple, not in terms of the number of features and things we need to do to get this to work, but in general, the process should be able to be applied to whatever geometry you're making. Now, I do get some comments about doing things the wrong way before we get to doing things the right way. Now, in a lot of cases, I do think that that's important. And what I want to talk about here is using tools like the inspection tool and looking at curvature map analysis. And so, what I want to do is I want to kind of go through this example, not necessarily the wrong way, but a way that produces slightly worse geometry first. And then we'll do it a second way, which will produce better geometry. So this is the first way. Kind of see there's some hard transitions and edges from curvature that just kind of starts in the middle. Now, if we take a look at the other way here, let me go ahead and clear that selection. So what we see with this one is the transitions between the colors, the radius of curvature here, is a little bit better with the same exact settings. And so this is the idea. We want to be able to better control what this curvature map looks like and control where the radii are. And so again, I do get some comments about doing things the wrong way before we do them the right way, but it is important to understand the process. So let's get started with a brand new design. I'm going to use hybrid. And in the solid tools, we're just going to go to create and sphere. Create a sphere on any plane here and make it 100 millimeters. The size doesn't really matter, honestly, but we're using this as a representation of some sort of curvature, rounded shape, a helmet, whatever the case might be. And this is just a quick way to do it. So once we have this shape, we're going to split it up because we don't really need the whole thing. So I'm going to start with split body. We're going to split the sphere and we're going to use the right plane. So if you need to, hold down the left mouse button, select XZ and hit OK. Then this side we're going to remove because we don't need it. So right click and remove. Next, I'm going to go to my surface tools, select this inside face and hit delete. You can go to modify and delete or just hit the delete key. And now what we're left with is this sort of half sphere and we've got basically a surface to deal with. Now, if you rotate this around, you also notice there is a sort of weird spot that happens on even the default primitive here. And that's because when we revolve something, which is really how this is made, we're going to end up with that, what we call a degenerative point. And this is where the surfaces are kind of bunching together. We're not using that to drive any curvature in our case, just something to keep in mind if you are using the sphere. All right, so there's a couple steps to this. And you can obviously choose whatever way you want to go about it. But for me, I generally try to split the surface faces up where I need to create some divisions. And so first thing for me, I'm going to go ahead and create a sketch on the front plane. I'm going to do a line that is vertical, and then I'm going to do one that's sort of up at some angle. I'm going to just pick 45 or 50 degrees. We'll use 50 degrees here. And then we are going to use that as a split tool, and we're also going to create some planes to use as a split tool. So construct, offset plane, and we'll go minus, let's say minus 10 millimeters. And then we'll repeat that again. And we'll go minus 15. So now we're going to split face. We don't want to split body. We just still want a single surface. So select the surface and then the tool. If it's hard to see, expand your construction folders and go to plane 1. Hit enter. If you need to, spacebar or right click in the 12 o'clock position or repeat the last command. Those will speed up your workflow a bit. And then we can hide those planes. We don't really need to see them right now. And then we're going to repeat that again. We're going to split both of these two ringed faces and we'll use this as our tool. So now we've got some divisions here to work with. This surface can actually go away. And when we're in surfacing tools, if we select a face and hit delete, and again, modify and delete or just the delete key, those will go away. So that's the area that we want to blend. Now that we've got that sort of taken away. This area is going to go away as well, but I'm going to leave it for the time being so I've got this curve as a reference. So start a new sketch. Once again, we're going to use the front plane. We're going to project, so that's P on the keyboard, or you can find it from the inspect or the create menu. And then we're going to use create, arc, and a 3-point arc. Now the reason I'm using an arc here is because this is a sphere, so it's got a consistent radius around it. And so if I tried to use a spline, the geometry is going to be kind of messy. So what I want to do here is I want to use this arc, and I don't want it to cross this point because we're going to be fading down to that point. So just pick a place, kind of move it around. If you want to make it really drastic, you can have it kind of like an exhaust vent. Let's just assume this is a helmet, and then you can have it kind of large, or you can make it a little bit closer if you want it more subtle. I'm going to put it somewhere about there. If you want a dimension, looks like about 62 millimeters. This doesn't dimension the arc length, and so that's something where you'd have to come and put a couple of extra dimensions on. Typically for me, it's easier to do something like an angle. So if I wanted to fully dimension it, I could come to here and say, let's make it 45 degrees. And so that way, if you want exact numbers for what we did, I'll make those 2 vertical lines construction. If you want some exact numbers, there you go, 45 degrees, radius of 62. This is going to be used as a tangent reference, so we want to extrude it and pull it back. Doesn't matter how far, just as long as we've got something there. So that way, when we use it as an edge, because the arc was tangent up here, when we create a surface that essentially uses these 2 edges, we have tangency going this direction and tangency going this direction. So that's important, so we don't have anything kind of weird going on in that corner. Now we want to create a curve that's here. So that's our second plane. Actually, I'm sorry, that's our first plane. Right click and create a sketch. Once again, we need this as a reference. So create, project include, and project. And then we'll create another arc. So from here, again, we want a tangent arc. So we'll just go to where that tangency point is and then hit enter. Now here's the trick. You want to kind of be mindful of where this is out in space and what the radius is. So if you want this to get closer to the actual radius of the helmet, meaning the fade is going to be less extreme here, or if you want it to be closer to the radius of this, you can define that. Again, dimensions. If we say 62, you can see kind of what that looks like. It really needs to be smaller than that. Let's say 58. I hate how it zooms in and out. And then if you want to control where this is, it's probably best to go to project this endpoint, create a line from there back to the origin, assuming the origin, this is centered, this is a circle that's centered at the origin, so it helps. And then we'll make that construction. And so that kind of controls where that ends up. We'll finish the sketch. And now we can create a loft. So we're going to loft from here to here. That first one is going to be tangent, and we want to align to surface. And then the rail is going to be here, and that's going to be tangent. And then we can delete that. We don't need it. All right, next thing I want to do is select and delete that. Again, delete on the keyboard, and then stitch these together. All right, so here is the spot where we start to get the bad or the less than ideal surfaces. And there's a couple of reasons why. So the first thing I'll say is one of the more common ways to go about this that I see is lofting from here to here and using tangency on both. We want to make sure that these are typically aligned to the edges or the surfaces. In most cases, edges, and we have a video on this, but in most cases, edges and surfaces will produce the same thing. In this case, because the edges are split with a plane, they will produce the same thing. If you happen to have trimmed the surface, aligned to surface will follow the edge of that surface, where aligned to edges will follow what the original edge would have been. And so again, so this is one way that people go about this. We stitch these together. And then we patch this opening. And so group all the edges together, make them tangent, say okay, and then stitch these two things together. Now, this isn't necessarily bad. This might be perfectly fine, especially if you are 3D printing a design. It may not matter. But one of the sort of inception points that cause issues is the fact that we've got this sharp corner here. This one down here at the base of the shape doesn't really matter as much, but this one up here does because of how we're trying to patch this as a round corner. So that potentially causes problems. One way that we can get around this, and again, I'm going to go through and I'm going to sort of undo things. So I'm going to delete those two faces. I'm going to take this body, the entire thing, and I'm going to mirror it across the midline. I'm going to join them together. And now when I go to use the patch tool, it'll grab that entire edge. Again, grouped edges, tangent. This will give us a slightly different, slightly better result, but it still maintains the same issue. If we go to curvature map analysis, we take a look at this, and let's go ahead and bring this down. You'll see what we get here is we get these sort of spots in the corner. And let me grab these as well. We get these sort of spots in the corner, and you'll notice that they originate right there at that edge. All right, so I'm going to cancel that, and I don't need that section. All right, so what we're going to do is instead we are going to unstitch, it always does this, turn off chain selection. We're going to unstitch these two, and we'll hide the original body, just put them back together temporarily, and then we're going to thicken them. Now, the reason that we're thickening this is really just so that we can get a rounded corner. So we're going to modify, fillet, and we're going to round these corners here. This is the reason I'm doing it this way, and let's just add a 5mm fillet. The reason I'm doing it this way is because it is the easiest way to get a consistent fillet at the stage that we're at now. If we start to create curves, for example, trying to build the surface with that filleted corner, it will not be a consistent radius and you'll have a lot more difficulty making it consistent. So at this stage where we're at, it makes the most amount of sense to fillet those as a solid and then use a tool like offset, which is going to create a copy. And then we're left with, let's go back to this one here. And then we're left with this surface here that's got those nice rounded corners. So I'm going to stitch all this back together. And again, I know we're kind of going around and around to make this happen, but I think it's important that we see the reasons or some of the areas that cause problems. That way we can decide how much effort we want to put in. And so again, what we're going to do is we're going to make everything tangent or curvature continuous. Now, if you're wondering what the difference is, tangent is going to drive the direction of the curvature, and curvature continuous is going to try to match the radius of curvature at those edges. There is, if you expand this out, there is a little scale value here. It's 0.5 by default. In this case, I would say because these surfaces are not complex, they're consistent radii in all directions, that tangent is going to produce a cleaner result. If you do have complex surfaces, then a lot of times using curvature continuity is going to produce a better result. You need to play around with it and make sure that you just have a basic understanding of what the two differences are. So we're going to say, okay, I'm going to stitch all this together, which will turn it into a solid body since it's sealed. And then we'll go ahead and take a look at the curvature map analysis. So what we should see here is that instead of getting a sort of a sharp transition, and you can kind of see there's a little bit of a darker line there where the arc ends, because an arc is a consistent radius and a line has 0. This is not a straight line, but it does change the radii in that corner. But what we should see here is that we don't have an instant hotspot in the corner at those sharp edges, and we've got a really consistent or really gradual transition between those edges. It takes a little bit of extra work to get to this point, and I'm going to hide the edges with Control and 4. It takes extra work to get to this point, but I do think it's important, depending on what the end result is that you're looking for, that you understand the different mechanisms, the inputs that you have to make these shapes work. And so what I would say is, as you're designing something like this, whether it's a helmet or a feature on a car surface or anything else that you're building. Just keep in mind that there is generally going to be several steps in the process to make that final shape work. And generally, if you can work with symmetry, so for example, if the left and right side of this are exactly the same, work with half of it because that gives you the ability to build tangents, extruded surfaces that can be tangency references. And that will simplify the process in a lot of cases in terms of building the curvature out. Now, at some point, having both sides and patching, like for example, that surface is going to produce better results. It's going to be a bit easier. But early off in the design, you typically want to create things like divisions or split lines on your surfaces and isolate the faces you're creating by primary surfaces, so the ones that are driving the curvature, and then those secondary surfaces, things like these patches that are filling in empty areas. Now, we do have, obviously on this channel, there is a surface mastery playlist. I'm going to put this video in that playlist there. We also do have several surfacing courses on learneverythingaboutdesign.com. So there are some that go over advanced surfacing for injection molding, and we also have just some basic surfacing courses as well. So I'll leave links in the description for that if you're interested in looking at those. If you have any questions on this, please let me know. As always, thanks for watching, and we'll see you in the next one.